So our knowledge is really progressing at this point. We've completed quite a few different aspects and coding concepts since we first started this course. We've completed quite a few since the last time we learned how to properly document and structure our programs. So what today's lesson is all about extending that previous knowledge of proper structure and documentation to include the new elements that we've added. There's not too much. So just a quick little review. Our console, our programs are basically all structured like this. The very first thing in our program is our header, AFP-CMD. Everybody remembers that. The next thing is any libraries that we have in our program, whether that is something to do user input or whether that is some other library that's doing something else, something fancy. It's all there. Oh, I missed the bracket there. Fix that. There we go. So, following that, we have our class line. Nothing happens there. And then right below our class line is where we define all of our global variables. Below that, we see our main method. And this is where all the logic of our program really goes. Anything that's going to happen in our program happens here. Now, it may branch out to go call a subprogram. And our subprograms are all defined below the main method. This is the structure that every single one of your programs should follow. Okay. At this point, now what we're going to be doing is we're going to talk about how we work with this and how we include all these different elements so everything is readable. Remember, that is our goal for professional practice, readability. White space. So previously we mentioned breaking up our code into blocks. And those blocks were simply sequential code that was related by some goal or purpose. So it might have been one line, it might have been 5 lines that all worked towards one end goal. So that would be a code block. We did that in our main logic, but we also did that in our variables. So we might say, well, this block of variables is intended for this purpose, and this block is intended for that purpose. Right? It's not always just input, processing, storage, and output, because sometimes there might be subsections within those. Like processing, well, there's a lot of different things that can happen in the processing of a program, and they're not always related to one another. So you're going to have multiple blocks inside of that processing section. So since we first started learning about code blocks, we also discussed this idea of subprograms, which we know are actually code blocks themselves, mini programs within the program. Right? Now, with subprograms, we must remember two key places for white space in addition to our old style. Before and after the definition of every subprogram, we should have space. Right? So right after the main method, there should be space, and then there should be the first subprogram. After that one, there should be space, and then the next subprogram, and so on and so forth. Everything inside of our subprogram should be indented. This should not be new news, though, because we know that whenever we see a set of opening and closing brackets, everything inside should be indented, right? That's how we know that it belongs to those brackets. Okay. Oops, I killed that off. All right. So that's our first piece in terms of white space. Not a whole lot of change there. Documentation. Now this is where our big changes occur. We have to add new documentation to places that we didn't even exist in our programs before. So now that we are heavily using variables, it's important that we make sure that our variables are efficiently blocked in terms of their purpose, because we're going to be having more and more and more variables in our programs. Again, with the addition of subprograms, we need to introduce another form of documentation. Now, our programs themselves have a header and that AFP-CMD, and that header's purpose is to tell us what's going on in the entire program, the details. Well, every single subprogram is very unique and has a lot of features and parts of it, a lot of moving parts. So we want to kind of give every single subprogram its own header. So we either call that its method header or we call it the pre-post conditions. Every single subprogram needs one of these. Now, what's involved in there? Well, there are 3 pieces. The first one is the precondition. This is where you tell us what are the assumptions about any incoming data. What are the assumptions about the parameters? So for example, if you're creating a method that calculated the area of a rectangle, the assumptions about the length and width parameters would be that they would be positive numbers. That is an assumption that you're making. Whether that's true or not is another thing. But that's the assumption. The subprogram can only do its job given that assumption. Post condition is what is the end result or the return value when the subprogram is complete. So what's going to be given back? Is it some number? Is it nothing? I don't know. It depends on whether it's a function or a procedure. And then finally, the description section. So this is a brief, very brief, a brief description of what task the subprogram is doing and how it's doing it. Now remember, the definition of a subprogram is a mini program within a program that performs a single task. What is that single task? And if needed, how is it going about it? Couple quick little points. If your subprogram has no parameters, so that means that our precondition, which talks about parameters, should just say none. If you're making a procedure which doesn't return a value, that means your postcondition would be none. Okay? It should still be there. It should just say none. Now let's look at some examples. So this first one we have here is calculating the area of a rectangle, calc rectangle area. Now what you can see here is we have our pre, post, and description. I've shortened the names down to keep it nice and simple and readable. Our precondition, which talks about the parameters. Length is a valid number greater than 0. Width is a valid number greater than 0. It tells me everything I need to know about length and width in order for this program to work. Post. Return the resulting area as a double. You don't necessarily have to specify its type, but sometimes it's pertinent. So for example, if it makes a difference between whether it's returned as an integer or a double for calculation reasons or whatnot, that's important and you may want to say that. So here I say return the resulting area as a double. Down below, the description. So remember, this is describing the task. Calculate the area of a rectangle given a specific length and width. Tells me exactly what's going on. Okay. Inside the subprogram itself, you can see we still use proper code blocks, and we still document each code block with its own comment. Okay? So there's our pre, post, and description. The method header for every single method. Every single one's going to. So here's a couple quick examples. Now I've put a Java example and a C# example because this documentation note applies to both classes. It's really the same thing, and you can see that the code's almost identical as well. But anyways, let's take a look. So in this case, this is a procedure. I know it's a procedure because there's no return type. Oh, I missed my static. Missed it on both of them. Fixed. Good. Private static void output Stewie's mailing address. Guess what that does? Private static void output Stewie's mailing address. So in the Java version, it works exactly the same. The only difference is string starts with a capital S, and the way that we do output onto the screen is system.out.println. In C#, it's 100% identical, except string is a little s, and we display using console.writeLine. Okay. So what are our pre-post descriptions? Our pre-post conditions? Well, there's no parameters, so pre is none. There's no return value, so post is none. But it still needs a description. Output Stewie Griffin's mailing address to the screen. Important that I put that to the screen. C# has the exact same comments because it's the exact same stuff. So that's how we handle subprograms. But we also learned another new component to our programming called selection statements, and we learned a large variety of those. We learned if statements, we learned if-else statements, if-else-if statements, and switch statements. But at the end of the day, they're all choosing. They're choosing from a number of options. 1 option, 2 options, 25 million options. They're all choosing. So this is the way we document these things. And now let me be clear. Selection statements are just control structures. They control the flow of the program. Later on in the course, we're going to learn more different types of control structures, such as loops. And it doesn't matter what they do right now, but the point is that there are going to be more control structures, and they are going to get documented in the exact same way that I mentioned here. It's not going to change. So what is that way? Well, first, there should be one overall comment above the opening line describing the purpose of the whole control structure. So in the case of a selection statement, that means the original if statement. So in the example here, you can see the only place we have a comment for the if statement itself is at the very top. Perform the appropriate mathematical operation based on the user's choice. That tells me what is happening. What is the goal for the entire if statement? I don't need one for each else if or anything like that or else. I don't need that. I just need one comment that tells me what's the goal of the entire selection statement. Inside, you still document as necessary. So if there's 1 line of code or 5 blocks of code, you document every single block with one comment. Okay? which it says here, code inside selection statements should be put into blocks and documented accordingly, as you normally would. There should be no space between the closing brace of the ifs and if-else-ifs and the next else if. So what I'm saying here is there's no space between all of our selection options. So the if ends, the else if starts immediately. I don't want to see something like this because that just creates unreadable code. We don't want that. I want them right next to one another. Okay? Even with the final else one as well. Keep them together. Okay? Else ifs and else statements of an if statement do not get their own comment. Only their code within does. So there's no comment here. We don't need it. Okay? The only comment we get for the whole if structure is at the very, very top. If you feel the need to do some kind of documentation because there's something really specific and unique happening, and if that's the case, then you would do it inside of the statement, wherever that is. So you would do your documentation right there if it was absolutely necessary. But there's very few times when that's actually the case. Now this if statement simply uses this, gave the user this menu, and the user typed in a 1, 2, or 3, and then it makes its choice based on that 1, 2, or 3. If menu option is 1, then it calculates the addition of the two numbers. If it's 2, subtraction, and so on and so forth. So that's how we document our selection statements and really any control structure. There's going to be one comment above the entire control structure that tells us what is the goal of that control structure. So that's it. That's professional practice number 2. You now know how to fully document, fully space, fully align, fully structure, and fully place all of your code within your programs. Now it's just a matter of putting the right code and the right comments in there. Okay? Don't give us silly comments like making a choice. That's not helpful. The comment needs to be specific to the problem and appropriate to describe what's going on without me having to dig into the code. But it also needs to be short and concise. Okay, that's it. Good luck. See you next time.